Okay, so let's cover the other three groupings of our transformations. We did the business intelligence and the row transformations. First one let's take a look at now is the row set. Okay, so you remember in the row transformation that it added a column or columns to the output. Now there was still only one row set available at the end of it, but it just had an extra column. Well, the row set transformations will add another row set into your data flow. So visualize it like this. Let's see if I can do this. So you've got your source up here, and ultimately, you've got whatever destination that you might have. Okay, so you bring this into your regular transformation. So we could just do data conversion. Okay, the data conversion simply adds new columns for the converted data types, but there's still only one row set, one data set that gets passed to the destination, right? Okay, that's fairly simple. Now let me do this one more time. And so again, we've got a source and a destination, and I'm not going to mention a particular row set by name transform because there are several. I'll show you here. So some row set transform, and a lot of times you'll see abbreviated XFORM transform. And so now you have the choice between, do I send row set 1 to the destination, or do I send the original source to the destination? So now it's your choice. Which of the row sets do you want to send? You are creating a new data set, a new row set, and you're passing that then to either a destination or another transformation or some other terminator of some type. So let's just take a look at these. I think I kind of liked the way that worked last time, so let me bring this guy in, grab him, bring him down. All right, let's take a look here at the first one, the aggregate transformation. Okay, so this simply creates a new result set, a new row set, a new data set that contains aggregations. Min, max, count, uh, average, sum, those kinds of things. That's all it does. Nothing difficult about it. Just creates a new data set based on aggregations. You get to define the group by, you get to do all those fancy things. Now, if you use a percentage sampling transformation, you would say something like, go take 10% randomized of the input rows, so it's a random sampling of the input rows based on whatever percentage value that you chose. Okay, so it's a random 10%, a random 25%. You have a couple of other options with that as well. Okay. Let's drill down. I was pushing the wrong button. A pivot transformation tries to make easy work out of something that is actually quite difficult, and that's creating pivot tables or crosstab tables. This is where you are denormalizing a normalized data set. If you're not really familiar with crosstabs and pivot tables, I'm going to hold off on that discussion until we get to explaining pivot transformations and seeing some of those examples. But it's just designed to help make pivots very easy for you. The row sampling, this is very similar to your percentage sampling. So you can see down here. The difference here is that you're not specifying a percentage. You say, I want 1,000 rows. I want 1,500 rows as opposed to 10%. Same exact logic. It's just how you want to do it. The sort transformation creates a new data set, a new row set that is sorted according to the keys, K-E-Y-S, that you specify. Now, a lot of you might be wondering, why would I do that? I mean, can I just put an order by in the statement? Yeah, absolutely. You could put an order by in your source SQL, your source statement to bring that back. That may work. You could put a clustered index on the data and read from the clustered index, and it may already be sorted. But if you're dealing with data in a text file, for example, where you can't write a sort operator like an order by. Yet you are going to use some of the other operators like the merge that require sorted inputs. That's when you would use a sort. You'll see that in a couple of other pages from now. We'll talk about certain transformations that require sorted data for them to work. And the unpivot is our final one here. This is the opposite of the pivot table. It takes a pivot table and converts it into real live normalized data. Okay. Again, when we get into pivot tables and showing that, that's going to become much more interesting to us. Okay, let's take a look now at the split and join transformations here on the next page. So our fourth group, split and join. These are, you could have made a split transformations category followed by a join transformations category. They just kind of group these together in the documentation. The idea here is that with the split, then I'm allowed to take things and direct them to multiple outputs. With the join, I'm taking multiple inputs and creating a unified output. So they're kind of opposites of each other. Okay. With the split, I have multiple destinations. With the join, I have multiple inputs. So let's just walk down these. Let's do the cache. The cache transform we talked about earlier. I can't remember offhand if it was chapter 2 or 3, but we talked about how in a lookup transformation, how to use the cache connection manager. This actually loads up that cache connection manager for a lookup transform. I'm going to talk about the lookups here a little bit later in the video if you aren't familiar with what a lookup is. The conditional split, this is a favorite. I think most SSIS developers will find many uses for the conditional split. It's just like having a case operator in SQL. You are defining, you have multiple destinations, and depending on the value of the input row, you can redirect that row to whichever destination you want it to go. So just like in a case operator, you can say when first name equals Scott, then return Scott Wiggum. You could do the same here. You could say if first name equals Scott, send that to the SQL Server output. Else, send it to Excel. So you're splitting the output. Okay. The lookup transform, as I mentioned, I'm going to cover that one here in an upcoming slide. But this just does lookup tables. Okay. You can use live connections or you can use that little cache right there. Again, I'm intentionally not going deeper into that because I have several slides here in this video that I'm going to cover that with. Now the merge join, let's cover that one first. This is actually a fairly easy one for those of you with SQL minds to get. This will take two data sets and merge them together using a join algorithm. So imagine, I think about it like this. So let's say I've got, let's see if I, oops, wrong one. I gotta remember which one does my circle here. Not any of those. There we go. Sorry about that. So let's say that I have a data source from SQL Server. And then I have another data source from Excel. Okay. And we would define, if you are a SQL person, we would define these as having, this would be C, this would be A, and this would be B. And we would say, and I'm going to come down here and type this in, that A is things or rows in SQL Server that have no matching row in Excel. B would be rows in Excel that have no match in SQL Server. And then C would be rows that have a match on a specified column or group of columns. So the merge join transformation allows us to choose what type of join. I'm just giving you the 2-second introduction to join. If you don't get this, then you need to learn joins with our Transact SQL course, the queries course, for example. A full join is A, B, and C. So it's all of these. You get all of the results. An inner join is strictly C. Oh, come on. In other words, it only returns the rows from both sets that were identified as a match. And then in a left join, well, you get to define who is on the left. It just so happens the way that I drew this diagram that SQL Server is on the left of the diagram. And so because of that, it returns A plus C. If instead, if SQL Server had been written on the other side, where's my pen? So if this wasn't SQL Server, right, if it was switched, and then this was Excel over here, then a left join would return A plus C still, but the A would be the Excel data that had no match in SQL Server. Again, this is not the place to understand what joins are. If you are a little bit mystified as to how joins work and what they are, you need to take a look at the queries course on writing joins and visualizing joins and understanding them work. Because there's nothing different in SSIS than what I've just seen here. So the merge join. So you can do an inner left or a full join. You cannot do a right join, but you can actually get a right join to work by flipping things around to make the right side the left side. Now you also have the merge transformation, which I find very confusing, if not the most confusing of the transformations. Now, believe me, I know some of you guys are sitting there going, what? He just blew my mind with the merge transformation and he's now telling me this one's complicated? The merge transformation is not complicated, provided that you understand joins. As long as you understand joins, the merge transformation is easy. If you don't understand joins, then it's not something that you should be playing around with until you understand joins. Okay? So if you found it difficult what I just went through with the merge join transformation, you have some homework. Go learn joins. That might take you 2 years, I don't know, but it is what it is. So the merge transformation, this is not in any way related to the merge join transformation. Okay, these are just by happenstance or confusion stance, given the similar names here. The merge transformation is really similar to a union and not similar to a join. So at the end of running a merge transformation, you can see that you pass in 2 sorted inputs, and it will create a third input by stacking the results. So it works just like a union all. Just like a union all. The duplicates are included because it's a union all, but the only difference is that it is a sorted union all. And that it has, and I'll highlight this, 2 sorted inputs. Not 16 sorted inputs, not 5 sorted inputs, but 2 sorted input sets. So you remember at the start of this I said that the sort operator, you don't use it too often, but there are certain transformations that require it. Well, the merge transformation requires sorted input sets be passed in. The multicast. You'll use the multicast probably quite often if you're doing partition-based loading or loading data warehouses. This is where you just take the source data and you want to just copy it multiple times to different locations. Okay? You're not doing conditional splits. You're not doing, if the year is 2004, then I want to load it in this partition. If the year is 2005, I want to load it in that one. That'd be more the conditional split. The multicast, you're just broadcasting it to multiple locations. You want a copy stored in SQL Server, and you want an Excel spreadsheet emailed to you. You're copying the same data into multiple destinations. Okay. And the final one, the union all. This is most similar in this case to the merge. Okay. The difference here is that these are passing in unsorted data. Okay. So you're not passing in sorted data, and also you're not limited to 2 data sources. You can take 5 data sources, for example, to the union all and simply stack them on top of one another to create a single result set. Okay. Now, I had originally, when I started out, planned that this would become a single video, but I've talked too long. So why don't we end it here, and let's come back in the next video and finish out this slide.